Hi, this is Alex from devstories.eu. Shapely, Episode 1 of 8. You might be used to treating map geometries as basic lists of coordinates, used primarily to draw shapes on a screen. But when you need to calculate if a GPS track crosses a specific border, simple drawing logic falls apart. To do real mathematical spatial analysis, you need the spatial data model. First, we must clear up a common source of confusion regarding this model. Shapely operates strictly on a flat, two-dimensional Cartesian plane. You can provide x, y, and z coordinates when creating your geometries. Shapely will parse them and even store that z value in memory, but it completely ignores the z coordinate during any spatial analysis. If you ask for the distance between 2 points, Shapely calculates the flat 2D distance. It does not calculate 3D volumes or 3D distances. It is a purely planar library. Here is the key insight. Shapely is built on mathematical point set theory. It does not view a shape as just the handful of vertices you typed into your code. Instead, it treats every geometry as a rigorous set containing an infinite number of points. Under this model, every geometry divides the entire 2D plane into 3 distinct parts. The interior is the actual substance of the shape. The boundary is the edge that frames the shape. The exterior is the rest of the infinite plane that is not part of the shape. Consider modeling a city park to see how these concepts apply. You start with a water fountain, represented as a point geometry. A point is zero-dimensional. It represents a single, exact location on the plane. Because it has no length or area, its interior consists solely of that one specific coordinate. A point has no boundary at all. Every other coordinate on the entire Cartesian plane makes up its exterior. Next, you add a walking path leading to the fountain. This is modeled as a line string. A line string is a one-dimensional geometry defined by an ordered sequence of coordinate vertices. Even if you only pass it a start and an end coordinate, Shapely understands the line string as the infinite set of points forming the continuous path between them. The interior is the entire continuous length of the path. The boundary consists of exactly 2 points, the first starting coordinate and the last ending coordinate. Finally, you model the footprint of the city itself using a polygon. A polygon is a two-dimensional geometry with a measurable area. You define it using a closed ring of coordinates, meaning the first and last points are identical. This outer ring forms the boundary of the polygon. The interior is the infinite set of points enclosed within that boundary. Polygons can also contain holes, such as a restricted conservation zone inside the park. The edge of that hole simply acts as an inner boundary, cleanly separating the valid interior of the park from the empty exterior space inside the hole. Shapely does not see your geometry as a hollow wireframe of coordinates. It sees a continuous region of space mathematically divided into interior, boundary, and exterior. If you find these episodes helpful and want to support the show, search for devstories.eu on Patreon. That is all for this one. Thanks for listening and keep building.